So the composition here, it's this symbol, the open circle in between the two letters. And so what it really is you're taking the whole function and dropping it into another one. And for me, it's actually easier to just rewrite it in what I call function notation. So when you look at the second part where it's in this function notation, you guys tend to recognize it easier as G is in the middle of all the parentheses. So that means you're taking G and inputting it into the F. So when I see composition, I usually do rewrite it, and the letters stay in the same order left to right. This particular example is not too exciting, but so you are going to take G of X and drop it into F. And so the first one, you're going to take this 1 over X, you're going to bring it over here, and you're going to drop it right there. So my F is something being cubed. And when I bring G in and I drop it right here, I end up with 1 over X being cubed. 1 over X times 1 over X times 1 over X is equal to 1 over X cubed. So what's the domain of 1 over X cubed? That is correct. You can use any number you want as long as you're not using 0. Going in the other direction, G, composition, F. So this time it's saying take your F of X and you're going to drop it into function G. I should do it this way. So G is looking like 1 over X or 1 over the input, and then that's where X cubed will sit. So you end up with 1 over X cubed, which is the same function as you had over here. So again, so all real such that X is not equal to 0 again. Now, when you do a composition in both directions, it doesn't always turn out to be the same answer. So, the only reason we have these problems on here and on your worksheet is for you guys to kind of think about compositions and how they truly work. And again, trying to see if you guys understand function notation. It isn't something that we ask you to do, because in this type of problem, if I would ask you on an exam, it would be, there are lots of different answers. Okay. What I tend to do is start with, we're supposed to do F, composition G, which would be F, G of X. So we're going, whatever I put into G is going to be dropped into F. So the result looks like that. So I want to finish with 1 minus X quantity cubed. So whenever I do a problem like this, I just kind of think to myself, well, what seems to be in the very middle of the result there? So it looks like there's a 1 minus X, right? So I'm going to write that down as my first part. I'm going to start with the 1 minus X. If I want to pick 1 minus X up, I need some sort of X up here, so I'm going to take 1 over X and throw it into the X up top. What does it have to look like? The easiest would be, if it's just X cubed. So if you take 1 over X, or excuse me, 1 minus X, drop it into x here, you end up with 1 minus x cubed. I'll give you a few seconds. Look at B. If you see it right away, write it down. If you don't, look at your neighbors. So you take a 9 minus x, drop it into the square root of x, and then that will give us 9 minus x under the radical. Good? Good. We've done a couple of these problems back in Algebra 2. We're going to use the graphs to answer these questions down here. So, we're going to take -2, we're going to plug it into function f, and we're going to plug it into function g. So, find -2 on the graph. That would be right here. And I go up or down. You always go vertically to your function. So you take your input, which is your x value, and you either go up or down until you hit the function. In this case, I hit the function there, right? Then I bring that across to the y-axis, because the y-axis tells me what the output is. What's the output for function f? So when I did f of -2, we get 2. Then I'm going to do the same thing, function g. So let's do, we'll stick with the blue color. We're going over to g, which we start at -2, which would be here. And I go up, and I hit my function right there. I go across to the y-axis, and that will tell me the output. And that tells me an output of 1, 2, 3, 4. So it says we're supposed to add those two outputs together, and we get 6. That's how you use graphs to determine outputs. Make sense? They always tell you what to use for your x or your input. So you find that on the graph, and then you will go vertically. Because it's an x value, you either go up or down to hit your function. Wherever you hit your function, come back to the y-axis, and it'll tell you the output. Let's do B. So that's a division. So again, -1. We'll use red. So we're supposed to go to -1. -1 would be here. I go vertically to the x-axis, horizontally to the y-axis, and my output 3. Do that on G also. -1 would be right here. We go vertically to the function, horizontally to the output. So we're dividing those two. What's 3 divided by 3? That's the answer. I'm going to pause it again. So somebody near you, I want you to do C and C. Right. Do the last two, C and D. Okay? And then I'll go through them on board. All right, we'll go to green. So for the multiplication, using -3, that would be here. And then we bring it across to the y-axis. Give me a 1. Now we go over there. What are we doing? -3. So go to -3. I hit there. Bring it across. It's not marked or anything, but I believe it's a 5. So So I'm getting 5 for my answer. Good? What are we going to do in D? The composition. Okay. Go to blue. No, we've done blue. Orange. So if I go to 0, that's right here. Oh, I didn't switch that color. Bring that up. I hit my function right there. We're on the y-axis. My output is 2. Do I write that down, or what do I do with 2? What? Take that function, or that output, and the composition says, now that output is your input over here. So I'll go to 2, and I'll bring that up. So we're about right there, it looks like, and then so it looks like if this is 4, 5 would be about right there, and maybe 6 is that one. It's a little bit off. What? I don't believe we have any of those on the test. But those are they're kind of weird. Once in a while they'll show up on a standardized test. But it truly is just, when you have a graph, now I'm really testing to see if you guys understand the difference between inputs and outputs and how they work. So on the first 3, we do these inputs, and then we do something with their output. But on the last one with the composition, it's just a matter of that output cycles back in and is the input on this one. So, is this the last one? All right, I'm gonna